Zscaler deployments are tailored to each organization's unique requirements, following a structured approach that typically includes defining goals, creating a design plan, and implementing traffic forwarding methods such as tunneling, PAC Files, or the Zscaler app. Zscaler engineers provide professional deployment services as warranted in their end-user subscription agreement. Thank you for tuning into your SASE Gateway YouTube channel. Subscribe if you want more straightforward content like this about SASE and cybersecurity topics. Zscaler recommends a structured 4-phase deployment approach that balances thorough testing with efficient implementation. This methodology ensures minimal disruption to business operations while maximizing security benefits throughout the deployment process. The initial phase focuses on deploying Zscaler to a small group of IT staff who are familiar with the technology and can provide valuable feedback. This controlled environment allows administrators to validate basic functionality and connectivity, test policy configurations before wider deployment, identify and resolve potential issues early, and document the deployment process for subsequent phases. During this phase, organizations should work closely with Zscaler's Deployment Advisory Services, or DS, to establish a baseline configuration that meets the organization's minimum viable product requirements, typically covering about 1/4 of core security needs. After successful IT testing, the deployment expands to include a broader user base representing different departments and use cases. This means including users from various business units and geographic locations, testing different access scenarios and application requirements, gathering feedback on user experience and performance, and refining policies and configurations based on real-world usage. This phase represents the growth period where deployment expands from 1/4 to approximately 3/4 of the target implementation scope. Having a dedicated professional services consultant or Zscaler coach during this phase can significantly accelerate implementation and ensure thorough coverage of security requirements. With lessons learned from the pilot phase, organizations can confidently proceed with full-scale deployment. So here's what typically happens next. Implement a phased rollout strategy by department or location. Leverage automation for large-scale client deployment. Monitor system performance and user experience metrics, and of course provide user training and support resources. The final phase focuses on refining the implementation and integrating Zscaler with other security and identity solutions. Fine-tune security policies based on production data. Implement advanced features like data loss prevention or DLP. Integrate with identity providers for enhanced authentication. Connect with SIEM solutions for comprehensive security analytics. Many organizations integrate Zscaler with solutions like Duo for multi-factor authentication, Splunk for analytics, and Microsoft Azure AD for identity protection and management. This phase also includes deploying additional Zscaler technologies, such as application segmentation and role-based access controls. Zscaler Internet Access, or ZIA, offers multiple traffic forwarding methods to accommodate diverse network environments and user scenarios. Understanding these options is crucial for optimizing security coverage while maintaining performance across your organization. Transparent forwarding allows traffic redirection without requiring changes to your existing network infrastructure or end-user devices. So let's break down a few key methods. GRE tunnels are highly recommended for office environments. With GRE tunneling, traffic from your network devices is encapsulated and sent to Zscaler's service edge. This method provides inline traffic inspection without any endpoint configuration changes. and it even supports automatic failover between data centers. Now, IPSec tunnels work in a similar way, but with added encryption, making them suitable for organizations with specific security requirements. Proxy chaining, on the other hand, enables integration with your existing proxy infrastructure by forwarding traffic from your current proxy servers to Zscaler. All of these methods are ideal for fixed locations and support any type of traffic without requiring endpoint configuration. For mobile users, remote workers, and those road warriors who are working outside corporate networks, explicit forwarding provides security regardless of location. The Zscaler Client Connector, or ZCC, is a lightweight agent installed on user devices that creates secure tunnels to the nearest Zscaler data center. ZCC offers 2 tunnel modes: Tunnel 1.0, which inspects HTTP and HTTPS traffic on ports 80 and 443, and Tunnel 2.0, which supports inspection of all traffic types. PAC Files, or proxy auto configuration files, direct web traffic to Zscaler based on rules defined by administrators, which makes for an easy migration from existing proxy solutions. Zscaler recommends implementing a combination of forwarding methods to ensure comprehensive security coverage. You should use tunneling like GRE or IPSec for office locations and IoT devices. Deploy the Zscaler Client Connector for mobile users and remote workers. Implement PAC Files for specific browser-based scenarios. And consider Zscaler Cloud Connector for additional use cases. This multi-method approach ensures that all traffic, regardless of user location or device type, passes through Zscaler's security stack before reaching the internet or internal applications. Zscaler has deployed service edge devices in over 150 data centers globally, with peering at internet exchanges to minimize latency. This extensive distribution ensures users connect to the nearest service edge, eliminating the need for traffic backhauling and maintaining performance for web applications. When implementing ZCC for remote users, the service automatically selects the geographically closest node based on the user's location, with seamless failover capabilities in the event that a data center becomes unavailable. The Zscaler Client Connector, or ZCC, installation process is straightforward across multiple platforms, ensuring secure access to corporate resources regardless of user location. This lightweight agent serves as the cornerstone for connecting devices to Zscaler's cloud security services. Before installation, make sure your system meets these minimum requirements. For Windows, you'll need Windows 10 or 11, 64-bit, with 200 megabytes of disk space and 150 megabytes of memory. For Mac OS, you should have the current or one of the previous 2 major releases. On mobile devices, the latest iOS or Android versions are required. And for Linux, major distributions with current kernel versions are supported. Administrators can access the latest ZCC installers through the following steps. First, log into the Zscaler Client Connector portal. Next, navigate to the administration section, then select Client Connector App Store. After that, just click on the New Releases tab. The most recent stable release, which is currently version 4.6 as of early 2025, is typically listed right at the top of each platform section. Let's talk about the installation process by platform. For Windows installation, first, locate the downloaded NMSI installer in your Downloads folder, then accept the license agreement when prompted. Proceed through the custom setup options and click Install to complete the process. To verify installation, check for the ZCC icon in the system tray. For enterprise deployments, administrators can use command line options such as Zscaler Windows 4.4.0.379. Installer x64.msi user domain equals example.com. Additional installation parameters can customize the deployment experience. For example, cloud name specifies the organization's cloud name. Quiet enables silent installation. Hide Apuian launch prevents the user interface from appearing at launch. Strict enforcement enforces security policies, and policy token applies specific policy configurations. For macOS installation, start by extracting the downloaded zip file, open the installer package, and provide administrator credentials when prompted. Just follow the on-screen instructions to complete the setup. Finally, launch the app to verify proper installation. When it comes to mobile device installation for Android, open the Google Play Store and search for Zscaler Client Connector. Tap Install to download the application, then launch the app and grant the necessary permissions. Complete the setup process as prompted. For iOS, access the App Store and search for Zscaler Client Connector. Tap Get to install the application. Open the app from your home screen and follow the configuration instructions. For large-scale deployments, organizations should consider a few important factors. Customized installation can be achieved by using installer options to streamline user enrollment. Automated deployment is possible by leveraging MDM solutions or group policy for mass distribution. Update management involves configuring automatic updates or setting up controlled rollout schedules. For user authentication, implementing SAML-based authentication helps ensure seamless login experiences. After installation, administrators can manage policy decisions regarding updates and troubleshooting tools directly through the Zscaler administration portal, including capabilities for packet captures and log exports to really simplify maintenance and support. Zscaler's pilot implementation strategy represents a critical phase in the deployment process, bridging the gap between initial testing and full-scale production rollout. This strategic approach enables organizations to validate Zscaler's security capabilities in real-world scenarios while minimizing disruptions to business operations. The success of a Zscaler pilot largely depends on choosing appropriate participants. It's important to include users from different departments and geographic locations to test diverse use cases. Also, select a mix of technical and non-technical users, typically between 100 and 500 participants. It's a good idea to prioritize users who access business-critical applications to validate performance, and consider including executive sponsors to demonstrate value to leadership. Organizations implementing Zscaler should create a structured pilot group that represents the company's various workflows and application requirements. This diverse sampling helps identify potential issues across different user profiles before wider deployment. With proper planning, organizations can significantly compress their deployment timeline. For example, Zscaler professional services customers deploy an average of 1 quarter faster than those implementing independently. A well-executed pilot can transition to production in under 45 days with proper executive sponsorship. Quick start for ZIA implementations typically completes within 6 weeks for organizations meeting specific criteria. The state of Oregon's experience demonstrates this approach in practice as it conducted controlled pilot testing in select agencies with promising results before planning the broader implementation of Zscaler as part of its Zero Trust Network access strategy. During the pilot phase, several key technical configurations should be implemented and tested. First, you need to configure machine tunnels for pre-logon connectivity to on-premises resources. Next, set up Windows policies with appropriate machine tokens for seamless authentication. Then, deploy Zscaler Client connector using management tools like Microsoft Intune with custom options tailored to your environment. It's also important to test integration with identity providers and your existing security infrastructure. For organizations using Microsoft environments, the pilot phase should include testing Zscaler's integration with Windows Autopilot. This enables the Zscaler Client Connector to install automatically during device provisioning, which in turn provides access to on-premises Active Directory resources. Establishing clear success metrics is just essential for evaluating pilot effectiveness. You should monitor user experience and collect structured feedback. It's also important to track security incident detection and prevention rates, as well as measure performance impacts on critical applications. Be sure to document any deployment challenges and their resolutions along the way. Organizations should establish a formal feedback mechanism for pilot users to report any issues or provide suggestions. This data becomes invaluable when refining configurations before production deployment. The transition strategy should include analyzing pilot results and addressing any identified issues. You'll want to refine security policies based on real-world usage patterns and develop a phased rollout plan for the remaining user population. It's also helpful to create user communication and training materials based on pilot user experiences. Successful pilots typically expand implementation scope from approximately 1/4 to 3/4 of the target security requirements, establishing a solid foundation for the production rollout phase. By following this structured approach to pilot implementation, organizations can ensure their Zscaler deployment delivers maximum security benefits while maintaining user productivity and satisfaction. PAC, or proxy auto configuration files, play a crucial role in Zscaler's traffic forwarding strategy. However, their implementation really varies depending on your deployment scenario. For organizations transitioning to Zscaler, understanding the distinction between forward PAC and app PAC files is, essential for proper configuration. Forward PAC files determine whether traffic should be routed through Zscaler tunnels or bypassed to connect directly to destinations. In tunnel mode, the forward PAC is the primary mechanism for controlling traffic routing. This file contains rules that specify which traffic should bypass Zscaler Client Connector and which should be tunneled to the Zscaler service edge. App PAC files, on the other hand, are primarily used in non-tunnel deployments to direct web traffic to Zscaler proxy services. And operating in tunnel mode, particularly tunnel 2.0, the app PAC becomes less relevant as traffic routing is handled at the network adapter level rather than the browser level. When implementing Zscaler Client Connector in tunnel mode, you should use only the forwarding profile PAC file to determine which traffic should bypass Zscaler. The syntax for PAC files remains consistent across tunnel implementations, so there's no need to write separate PAC files for different profiles. For tunnel 2.0 deployments, configure specific bypasses through the hostname or IP address for VPN gateway bypass section in the administration portal. Tunnel 2.0 offers more comprehensive traffic capture capabilities compared to browser-based PAC file implementations. It intercepts traffic at the adapter level, allowing for inspection of all protocols and ports, not just web traffic. When configuring PAC files for Zscaler Client Connector, it's best to keep rules simple and focused on specific bypass requirements. Make sure to test PAC file configurations thoroughly during pilot phases. Also, consider the destination of traffic when determining forwarding methods. Remember that DNS requests are tunneled to the Zscaler cloud for resolution. Regardless of the DNS server configured via DHCP. For organizations transitioning from traditional proxy deployments to Zscaler's tunnel-based approach, it's important to note that browser-defined intranet site configurations may be lost when removing PAC file configurations. This should definitely be considered during the migration planning process. By properly implementing and understanding the relationship between forward PAC and app PAC files, organizations can ensure optimal traffic routing while maintaining security and performance across their Zscaler deployment.